Hi, everyone. Welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Grant. Grant, welcome to the podcast. Would you like to introduce yourself?
Yeah, thanks, Tom, for having me. I'm Grant Gibson, Chief Development Officer with Synthica Energy.
Fantastic. And who or what are Synthica Energy, Grant?
Yeah, so Synthica Energy is a developer of anaerobic digestion facilities focused in various markets across the US. We use different types of what I call industrial byproducts off of food and beverage manufacturing, to where we use the byproducts from those processes and then run them through the anaerobic digestion process. And on the backside of our plant, we end up producing renewable natural gas. Renewable natural gas is very similar to natural gas. When you put one unit of renewable natural gas side by side with conventional natural gas, burns the same, has the same heat value. The big difference with renewable natural gas is that you don't have the carbon emissions that you do with conventional natural gas. So,
Yeah, I mean, chemically, it's the same thing.
exactly. Yes, it is.
Cool. Great. Yeah, it's just in how you create it. Yeah, cool. So, walk me through a little bit, Grant, through the origin story of Synthica Energy, because as far as I understand, you're also a co-founder, right?
Yes, I am. I'm a co-founder. So my business partner, Sam, and I started it back in 2017. Sam and I have known each other for 20 plus years. We've been friends, share a love for the outdoors, rock climbing, backpacking, you name it. We reconnected as friends, as many people know when you have kids, and sometimes you part ways with friends and then you come back to the middle of the road and you reconnect and you find out what they've been doing and then they find out what you've been doing and vice versa, and et cetera. So we reconnected as friends back in late 2016, early 2017. And we really got together and said, hey, look, you've worked in businesses with me and I've worked in your businesses as well. And we really just agreed that we wanted to build something cool. And I literally jokingly said, oh, we should build a digester. And he said, well, what's that? And I'm like, well, and I explained it. And I said, no, it's a terrible idea. Literally, that's what I said to him, because it's long, a tremendous amount of work, complex, etc. And we actually started down the path of reaching back out to customers that I had from a past career in commercial composting. And from there, we started to continue to work more and more on it. He already had the brand Synthica sitting around because he wanted to do something in really synthetic fuels. So the name Synthica was around. And we got to a point where we both said, all right, we kind of need a brand name for this. And he's like, well, I got this website park that's called Synthica. What do you think about that? I'm like, oh, that sounds fine. Let's use it. And so then fast forward, again, more and more work was put into it. We raised some seed money to get the permit to install from the state of Ohio EPA for our Cincinnati facility. And then we went through and formed a JV with a natural gas utility out of Pennsylvania called UGI. That helped get the Cincinnati facility up and off the ground. And at that point in time, we said, wow, could we do this across other markets, meaning Atlanta, Houston, San Antonio, other markets across the US? And the answer was yes. We ended up finding out there was a big need for the type of service that anaerobic digestion provides. And so we started working in other markets and going after permits. And yeah, that's a little bit of the story. And through today, we did a big equity investment with Goldman Sachs last August,
Nice.
which really has allowed us to grow the company, not only people-wise, but also fund the projects that we have on deck to be built this year and into next year.
Fantastic. Congratulations.
Thank you.
Why anaerobic digestion? I mean, that's not one that, instantly comes to mind. What was it that interested you in anaerobic digestion?
Yeah, so during my career as a commercial composter, I met folks at Procter & Gamble. And during that time, when we got to talking about the feedstocks or the waste streams that I was composting, and when I talk about composting, I was doing it at a commercial scale. We were taking in, on our peak, 250, 300 tons a day of all different types of food byproducts, paper sludge, yard waste. And so they came to me and they said, hey, you've got these feedstocks that are coming in the door that you're managing and composting. We've got a business center up the road. We'd love to build a digester on your compost site and then use the same feedstocks to power the digester, feed the digester, and then we'll pipe the gas up to our business center, pipe the renewable natural gas up to our business center. And so that's really where the idea was born. It didn't come to fruition, obviously, but that idea stuck with me. And then that's when Sam and I reconnected, and the idea was kind of lingering in the back of my mind of what is something that is pretty darn cool at the end of the day that we could build together. When he and I started on that journey, it was truly just a pipe dream. I mean, we didn't really think it was going to take off to where it is today.
Sure. And when you initially said to him it was a terrible idea, why did you say that?
I joke and I say we figure out some of the most complicated puzzles that could ever be put in front of someone, because with an anaerobic digester you have to figure out, and we learned a lot from touring other digester sites in the US.
Okay.
And so when you take the complexity of learning what's worked and what didn't work for other digesters across the US, and not to mention that there's not a large number of anaerobic digesters across the US. So in comparison to, say, for example, in Europe, where when you look at the complexities associated with anaerobic digesters, we set out, and when I say we, Sam and I set out to locate these digesters in heavy industrial areas. And so when you couple that with finding the right zoning, finding an area where you can, a property that you can inject the renewable natural gas, and then also have access to industrial sewer. So we do produce a wastewater on the backside. So zoning, an interconnect of where you can inject the gas, industrial sewer, and then concentration of nearby food and beverage manufacturing. And then not to mention also just the ability to the access of basically truck traffic getting in and out of your location. You take all of those and you say, all right, how many properties do you have at your fingertips or what's available? Mm-hmm. It becomes a very, very, very small number. And so figuring out all those parts and pieces, then not to mention the fact that most utilities that you approach and say, hey, I'm going to build an anaerobic digester in your footprint. And oh, by the way, I want to inject this thing called renewable natural gas into your natural gas pipelines. And they say, hold on, time out. This is a first of its kind project in our footprint. We're going to have to think about that, or go ask 50 different advisors and consultants and you name it in order to say that, okay, as a utility, we're comfortable with it. A lot has changed in the last, call it 5 to 7 years, as far as utilities being comfortable with it. But again, there are so many complexities associated with locating in a heavy industrial area to where it's convenient for food and beverage manufacturers to where they're not driving their byproducts or their waste long distances. So yeah, that's why I joke and say it was a terrible idea. I said it's a terrible idea because just the number of complexities associated with that type of facility.
Okay. And walk me through then what it is you guys are doing. You're taking waste products from industry, digesting it anaerobically, creating gas, plus, as you mentioned, water, plus there's obviously some solid matter left over at the end. Who are the customers for those, I don't know, 1, 2, 3 products, and who is it you're typically buying the stock from, feedstock?
Yeah, so I'll start with that last piece first. In the US, it's a little different. We actually get paid to take, we actually have a tipping fee for the waste streams.
Nice.
So a little different there, where let's say if you're a beverage producer, let's say a brewery, and you have a spent yeast waste stream that comes off of your brewery. Not necessarily it's the spent grains, because the spent grains are typically going out for animal feed, where it's the spent yeast. So it's like the yeast, the hops, water, other byproducts of the brewing process. The brewery is actually able to send that to us in a tanker truck where they offload it straight into the process. We get paid a tipping fee per gallon. Now, if we look at the back, what I call the backside of the plant, to your point, Tom, around, so when the waste, I'll call it a heavy wastewater, comes out of the plant. And when I say heavy, meaning it's mixed with, to your point, solids, we call it a digestate. So it's a solids and a liquid mix. So it's a slurry almost, where it comes out. We've harvested all the energy off of it anaerobically to where we're left with this super high nutrient digestate. We actually take it from there and centrifuge out the solids.
Right.
And that's, again, when I mentioned earlier about learning a lot of lessons along the way with all the different digesters. We centrifuge out the solids. So we spin it out. Think of it like your washing machine where it's spinning, sending all the liquid out, keeping your clothes inside. We actually take the solids from the centrifuge and then send that out to beneficial reuse. Everybody from composters to soil manufacturers, that kind of thing. So it's a much smaller volume, more dense, more of a solid kind of, we call it a cake, to where we're able to send that out for beneficial reuse. Then the liquid fraction, what we call the effluent, we have on-site pretreatment. So we take it from call it a higher strength, and we knock it down to what I'll call household sewage strength. And then from there, we discharge straight to sewer. Sewer districts don't like super high organic loaded waste streams, liquid waste streams. Sure. So through our process, we're knocking down that high strength organics all the way down to very, very, very small numbers. And then also we knock it down from a higher strength in a different sense to where it's more that household sewage, to where the local sewer districts absolutely love that type of material, that waste coming down the drain. So that's how we offload that solid fraction of the digestate, the liquid fraction, and then the gas piece of it. We generate two different, call it, products there. One is the actual physical gas, the molecules. So we send it out to, whether it's a marketer, whether it's a marketer of natural gas, it's traded just like traditional, what's in the pipe today, natural gas. Marketer, a utility can buy it, whoever. Then we also have a piece, what we call, some folks refer to it as a renewable thermal credit. Some other folks call it like renewable energy credit. It really is all the same thing, to where if you're and we focus on customers for the environmental attribute piece of it. We focus on customers that say, hey, I know that I'm not required by regulation to buy these environmental attributes to reduce my emissions, but I'm going to go ahead and do it anyways. It's what's called the voluntary market. And so we sell into the voluntary market. So it could be utilities that don't necessarily have a federal or any kind of regulatory requirement to buy environmental attributes. It could be a utility, it could be a private corporation, a large corporation that wants to lower their emissions based on buying those environmental attributes. It's a whole wide range of different customers. We don't focus on what's considered a low carbon fuel market out on the west coast of the US. We do focus heavily on the voluntary market. So that's kind of like, again, where the solid liquid fraction goes, and then physical molecules of the gas, and then also the environmental attributes.
Okay. And the solids that you're giving out for beneficial use, is that you're giving it away, or you're selling it, or which?
Yeah, I would love to say that we're selling it. It's one of those things where we try to do low cost, no cost, but we do have a cost associated with offloading it, because there's transportation associated with hauling it from our digester location to a composter, a mulch manufacturer, you name it. So,
okay, fair enough. I was speaking recently to a pharmaceutical company, and we were talking about their emissions, and one of their big sources of emissions is obviously industrial heat. So I can imagine for industrial customers, I mean, lots of different industries use fossil fuels for industrial heat, not just pharma. Is that a market you're chasing? Is that market chasing you?
that's a great question. So I would say yes, it's a little bit of chasing us, because that pharmaceutical company, that's a great example of the voluntary market. They say, hey, our biggest emission is heating, right? And so within the anaerobic digestion market in the US, and well, more so around renewable natural gas market, there is a tremendous amount of demand, but the amount of supply is just nowhere near coming close to meeting the demand.
Right.
So supply being small, demand being really big. I would say that when I look at and if you notice, I didn't really mention it being part of the complexity of that big puzzle that I talked about earlier,
Sure.
where offloading, having an offtake for the environmental attributes piece of it and the physical molecules, that's the easy part because there's so much demand for it. It's, oh, here's a term sheet, here's a term sheet, here's a term sheet from all these different providers. And it's just a matter of, okay, who do we want as a customer on the offtake side? Who are they? Are they going to be around in 10, 15, 20 years? That kind of thing. So yeah, demand is really high for it. Yeah, absolutely chasing us.
Nice, nice. Does that mean you can charge a premium for renewable natural gas versus regular fossil fuel gas?
Absolutely. Yeah. When it comes to the environmental attributes piece, you can. The physical molecule gas just gets traded at called a commodity rate and sold at a commodity rate to where, but the environmental attributes is really where that big premium comes in. If you look at, call it, it's probably, if you said in the US, the commodity rate right now for natural gas is traded at, I'm going to round up and say $3. For the environmental attribute piece of that, you're probably looking at a 7 to 8x on that.
Oh.
So you're at 21 to 24 per unit for environmental attribute associated with the RNG. So yeah, it's definitely a premium. Do I ever see it leveling out and going down? Maybe. It's possible. It just depends on what the industry does over the next 10 years.
Right. And sourcing your sites, how do you go about deciding where to build your digester? Is it, do you build them in your customer's backyard, or do you build it where it's most convenient for you and then get the gas from there to your customer by tanker truck, by whatever else means, by piping, whatever?
Yeah, so we try to locate in a region where there's a high concentration of food and beverage manufacturing. We've looked at what we call co-locating, like on the same property of a large food or beverage manufacturer. That tends to get pretty sticky just because of risk, liability, you name it, on both sides,
Sure.
both our side and their side. So it's interesting because I never thought in a million years that I would be using what I went to school for, which is geographic information systems.
Right.
I went to school for that at Ohio University in Ohio, and I never thought that I'd be using that one day to cite digester locations. So a lot of mapping, a lot of geospatial analysis, you name it. And so that helps us really whittle things down, the options down pretty fast so I can overlay. And we've got team members that do that today, where they'll overlay dots on a map that show concentrations of food and beverage manufacturing. They'll overlay the zoning. They'll overlay pipelines. They'll overlay all these different layers. And it, again, as I mentioned, it'll really whittle down the options that we have when it comes to property. So yeah, I mean, we try to do it pretty quick to where we can give it a quick pass or fail, and then we can move on to the next property kind of thing. If we find a property and we say, ooh, that looks good, it meets all the criteria, before we even put boots on the ground. So yeah, it's, again, I never thought I would be using it, what I went to school for, how many ever years later, 21 years later, that I'd be using it to site anaerobic digesters across the US.
Okay. And is there anything particularly unique about your anaerobic digesters versus anyone else who's doing anaerobic digestion?
So we don't use anything proprietary. We don't have any proprietary technology. We use commercial off-the-shelf equipment, whether it's blowers, tanks, mixers, receiving equipment, you name it. It's all very, very, very standard stuff. Where the big differentiator for us is, one is the convenience of where we're located. If you compare us to other developers of digestion facilities, typically has been further out in more farm or rural settings.
Right.
We do not digest, we do not take in manure from whether it's cattle or swine. So that's a big differentiator right there. The second to that is the fact that we have the ability to offer up our offering to a customer that says, hey, I want to give you 20,000 tons of this particular waste stream, and yeah, I'm going to pay you for it to get rid of it. What do I get in return? We have different offerings that we're able to provide to that customer to where it's more than just an outlet. Because we know and we've learned over the last couple of years that we have to be more than just an outlet for them, for that manufacturer to say, oh, I send it to a digester. Yeah, it's great. Everything's merry. But for them, really, what's a true compelling reason for them to go through? I don't want to say the headache, but just the exercise and the commitment to say, okay, we're going to send it Synthica versus sending it to whether it's land application or sending it down the drain or even landfill, right? Because truly, yeah, economics are a big driver. Are we cheaper than the landfill? Sometimes yes, sometimes no. Are we cheaper than the sewer department or the sewer district for sending a liquid waste down the drain? Sometimes we are, sometimes we aren't. It really just becomes an exercise of, okay, where are they sending it today? How much are they paying today? Meaning the manufacturer. And then from there, it's, okay, if you send us 20,000 tons of waste, we have these other offerings that we can provide, kind of call it conversion as a service, where we're acting as infrastructure or even infrastructure as a service, to where we have different products that we can offer in return outside of what I mentioned earlier. So,
Okay. And are you thinking at all of maybe licensing the technology for other people to use? So you build a digester and license someone to use it, or sell them the blueprint so that they can create their own based on your model and charge them a fee, or just as a way to scale?
No, we really haven't thought about that. I guess the primary reason for that is because if you look at the markets that we're building in San Antonio, Texas, Houston, Texas, Atlanta, Georgia, basically we're going to be south of Louisville, Kentucky. We're going to be right outside of New Orleans, Louisiana. If you look at all those markets, there's no infrastructure at all. And so we are experiencing first mover advantage in purely the organic space. And when I say the organics, meaning we don't take in manure, we don't take in treated sewage from municipal wastewater treatment. We're focusing 100% on food and beverage or industrial byproducts. So I haven't really thought that way, just because there's no real infrastructure right now as it stands. So we're saying, hey, look, let's do it ourselves. Let's go out. Now, are we building them on our own? No, we're bringing in contracting firms to do all of that, because in order to scale, we don't need a construction arm. There are plenty of design build firms out there that can help us scale pretty quickly.
Okay. And why not manure, and why food and beverage?
Yeah, so a couple things. One is, as I mentioned earlier, around the location. Typically, on-farm digestion, those digestion facilities are either paying for the manure or they're taking it at no cost.
Right.
And so when you look at their top lines of revenue, we have three, where we have tipping fees, physical molecule gas, and then environmental attributes. And then we don't rely heavily on the low carbon fuel markets out in the West Coast. So we, over the first few years that Sam and I were putting Synthica together, is that we said, look, the low carbon fuel market is pretty risky. The credits that are available through that market can shift with political winds. And so I joke and say, at the stroke of a pen, those credits are associated with low carbon fuel market can change overnight. And if you're relying heavily on one revenue stream just from that low carbon fuel market, your business can have a major impact on the digestion facility from a livelihood perspective. So we've strayed away from manure. It is what I call relatively saturated. All the big dairies and most of the large swine farms are spoken for. They've been producing renewable natural gas for a number of years now. Now developers are out scrambling around trying to connect dots between a bunch of small ones to make a larger one, call it larger production of RNG. So we really haven't gone after that because we want to build, we both agreed, Sam and I both agreed that we wanted to build the infrastructure in, call it the urban areas where it's really, really needed versus having to haul waste further and further out to those on-farm digestion facilities. So,
Okay, that makes sense, I guess. Yeah, yeah. And looking forward, are there any particular innovations in anaerobic digestion technology or processes that you see as kind of game changers for the system?
yeah, so capturing all the tail gases associated with when you, in the last step of anaerobic digestion, you produce raw biomethane. And then from there, you have to upgrade it. So you're stripping out moisture, CO2, hydrogen sulfide, reducing oxygen content, you name it. And so those are all considered tail gases. And so being able to capture all of the CO2 at a rate that makes sense, meaning from an equipment capex versus return. So that's one that we're doing right now. That should add a lot, hopefully. And then even as you start to build larger facilities potentially, that rather than sending out your cake for beneficial reuse, are there ways that you can run that cake through pyrolysis or different types of thermal treatments to where you can basically create a syngas and then send that syngas back into you can run that syngas into the upgrader and then help produce even more RNG. So yeah, there's a couple different avenues that we're working on right now that can really, don't know if I call it game changers, but it definitely helps us a lot because we do want to capture everything that we produce and make sure that we're not creating additional burden. We're actually decreasing burden on the earth from environmental perspective. So yeah, I would say that those are the two big ones for us. I don't see anything like monumental in the next couple of years changing for us, but I mean, that could all change with the way technology is advancing.
Yeah. And what are you doing with the tail gases?
Yeah, so we're working right now actively to capture all those tail gases because with our first facility in Cincinnati, it'll come online here later this year, and we hope to have that ready to go by the time it comes online. So capturing those tail gases, specifically the CO2. So it's not a large volume, but it's a volume large enough to where it makes sense to spend the time, the effort, and the money on installing equipment and partnering with a company that does that.
For what end?
Yeah, so you can capture the CO2 and you can actually because our tail gas, our CO2 tail gas is like 98.9 or almost 99% pure. So you can actually produce food grade CO2 from that. So for carbonating, you name it. Yep.
Right. Okay. And what about any policy changes or incentives? I mean, the IRA was just, as an Irish person, I shouldn't be saying IRA loosely, but the Infrastructure Act in the US or the Inflation Reduction Act. Are there any policy changes? Has that helped, for example, or are there other policy changes that could or should be made that would help?
There seems to be more and more states adopting a renewable fuel standard. I know New Mexico just adopted one. I think Michigan is pretty close. I think a few states on the East Coast are close. I think the more states that adopt a renewable fuel standard will encourage more and more RNG production. But again, it lends itself back to the credit market where you have renewable fuel standards out west that are part of that low carbon fuel market to where, again, you want to make sure that you foster growth and adopt into alternative fuels, but at the same time, you have to make sure that you don't have catastrophic market events, whether it's a shift in policy once the RFS is set up, and then if you have a major shift in policy that can, again, create a catastrophic event. But I think the more and more that states adopt renewable fuel standards, I think that'll help a lot. I mean, Yeah, and then we'll see what I know that more and more large truck engine manufacturers are coming out with engines more geared towards compressed natural gas. And I mean, you can do the same with RNG pretty easily. It's the same. It just, instead of just CNG, it's RCNG. So yeah, we'll see what happens. I mean, from the equipment standpoint, and then also on the policy side at the state level, I think those will provide additional growth areas for the industry as a whole.
Okay, fantastic. There's a lot of talk these days, Grant, about circular economy. And what you're doing with anaerobic digestion is obviously circular, particularly if you were taking that food waste in, doing the digestion, and then selling the gas back to the companies from whom you bought the food or food waste, or who you didn't buy it, who you accepted the food waste from. Is that an angle you're using in selling the gas or in marketing what you do?
Yes, absolutely. I mean, that's where I was alluding to that earlier around just part of the what makes us different is that we're able to offer different products in return. So when it comes to the environmental attributes piece of it, so if a manufacturer says, "Hey, I want to send you 20,000 tons a year," then we're able to create that circularity to where the waste can come to us, produces the renewable fuel, and then from there, we're able to send back not only physical molecules being the RNG, but then also the environmental attributes as well. So, yes, absolutely.
Okay, cool, cool. We're coming towards the end of the podcast now, Grant. Is there any question I did not ask that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
I mean, not off the top of my head. I mean, I think one of the things that we have been doing a lot of recently is community interaction when it comes to working with different community organizations to where one of the things that we want is we want people to understand that hey, there is this thing called anaerobic digestion, and then you could also have a career in it. That's one of the things that we've been partnering with different organizations and across a couple of the different markets we're in because we want to provide educational tools to where that youth can go and tour and understand, oh, hey, this is what an anaerobic digester does, this is what it produces, and that there is this potential career for me. And it's much different than anything else that's out there. So yeah, we've been doing a lot of that. I think that'll just become more and more important to us as we advance our facilities in the different markets. Because one, we always want to be a good neighbor and a big part and contributor of the local community because not only from a jobs perspective, I mean, we're not a large job creator as far as the number of people that we'll have employed at each facility. But when it comes to the education piece, I mean, and it's just like when I look back at what I did in commercial composting, I mean, I felt like I was doing like, when the weather was decent out, I was doing a tour almost every single day during the week.
Wow.
And the same applies to our facilities because we want people to understand that, hey, there is this way to not send waste, whether it's down the drain to the landfill for land application, whatever it may be, that we can actually capture the energy from it and produce this renewable fuel in a way that really just makes sense for everybody. So
Nice, nice, good, great, great. Grant, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
yeah, we'd have everybody go to our website, which is www.synthica.com. So synthica.com.
Cool, great. Grant, that's been fascinating. Thanks a million for coming on the podcast today.
Yep, Tom, thanks. Greatly appreciate you having me on.